All right, guys, we're going to be looking at exponential point ratio form, or finding the ratio if there's gaps in data and building an exponential equation. So let's start with some application now. It says the length of time that milk and many other perishable substances will stay fresh depends on the storage temperature. Suppose that milk will stay fresh for 146 hours in a refrigerator at 4 degrees Celsius. Well, that is left out in the kitchen at 22 degrees Celsius will keep for only 42 hours. Because bacteria grows exponentially, you can assume that freshness decays exponentially. All right, so the first thing we are going to look at in this case is understanding the basic setup for the points. Okay, and that's going to be really important. We know that the freshness of milk depends on the temperature of the refrigerator. So when we set up our X, Y values, so we set up X and Y, we're going to be thinking of it in terms of the temperature, and that's going to dictate the freshness of the milk. Okay, so just looking at this information that's given to us, it tells us that we have the temperature of 4 degrees Celsius will give us a freshness of 146 hours. And then from there on out, we know that 22 degrees Celsius will give us a freshness of 42 hours, because as it gets warmer, we all know milk gets a little bit grosser. So now what we want to do is we want to go back to this idea that we have an exponential equation that we have to build. And that is the purpose of this. So I say, well, y equals to a b to the x is our exponential equation, and b, which is going to be our rate. We're going to start by looking at the fact that we know we end with 42 and we end with 146. So let's take 42 and divide it by 146. Okay, so let's do that. I'm going to go 140 or 42 divided by 146. And we get this lovely number of 0.2876. Let's go with 0.288. Okay, so this is 0.288. And what we also know is that there is a gap in the domain, or the gap in the x values, okay? And that gap is 18. It is size 18. And what that means is the rate is going from, to get to the 5th term, we multiply by our rate. To get to the 6th term, we multiply by our rate. To get to the 7th term, we multiply by our rate. And what we really end up doing is multiplying by the rate 18 times. So we can rewrite it as r to the 18th power equals to 0.288. Well, how do we get rid of that 18th power? Nice and easy. We use the 1 over 18 power. So I just use the reciprocal, 1 over 18. Okay. These are going to cancel, and when that occurs, r is going to come out, and we're left with 0.288 to the 18th, 1 over 18 power. So 0.288, carry 1 divided by 18, and it gives us 0.933. So let's go ahead and write that, 0.933. Now, we can write two different equations out of this because this is point ratio. We can go ahead and write y equals to the original amount of 146 with our new rate of 0.933. But what we're saying is our initial has been translated 4 units to the right. So I'm going to write x minus 4 here. I can also rewrite this equation another way. I can go to this point, the 22, and I can say y equals to 42.933 x. Now we've shifted it to the right, 22 minus 22. Verifying in Desmos is going to be super important with this. So let's do that. I'm going to take 146 times 0.933 to the x, and I'm going to have to put this in parentheses, minus 4, which is our first point. And then I'll put it, first equation, I'll put in the other one, 42 times 0.933 caret to the x minus 22. And let me just verify those equations. Let's do this real quick. 146 Perfect, we've got them. Now what we're gonna do is make sure that they are the exact same equation, because that's what should happen. If they are the same equation, their graph should be the same. So I'm gonna come over to here, I'm gonna turn one of them off, and it should turn green, and it does turn green. And that tells us that we have actually made the equation in two different forms based off of a translated initial value.